Well, let's ask the question, what are some of these examples of fine-tuning? I'll give you just a few. Here is the uniform temperature of the cosmic microwave background radiation, or Q for short. This is finely tuned to 1 part in 10 to the 5th power, or 1 part in 100,000. So that's a pretty big number to be finely tuned for life, 1 part in 100,000. Now, if this was decreased by just 1 part, we would have no stars, no planets. If it was increased by only 1 part, the stars would be too close together and we'd have no stable planets. What about the weak nuclear force, one of the 4 fundamental forces of physics? This is finely tuned to 1 part in 10 to the 9th power. So 1 part in a billion. So what happens if this was not finely tuned precisely? Well, there would be no supernovae. That's the plural for supernova. And if you don't have supernovae, you don't have those life essential elements, the heavier elements, being seeded into the universe, which are necessary for life. So 1 part in a billion. But it gets worse. The omega constant, this is the mass density of the universe. This is finely tuned to 1 part in 10 raised to the 24th power. So as far as I'm aware, we don't have a name for that number. We have to write it out as an exponent. A 10 or a 1 with 24 zeros after it. If this wasn't perfectly finely tuned, if it was too high, the universe would have collapsed in on itself, no life. Or if it was too low, there'd be no galaxies and no stars. So again, I've heard people say, well, maybe evolution could have gone a different way. No galaxies. Well, yeah, but maybe natural selection. No stars. There would be nothing to evolve. None of the heavy elements, nothing on which it could evolve. What about the ratio of electrons to protons? This is finely tuned to 1 part in 10 to the 36th power. Friends, that's a 1 with 36 zeros after it. If this wasn't perfectly finely tuned, we would have no galaxies, no stars, just extremely diffuse gas. Well, maybe it could have evolved. This precedes the whole neo-Darwinian synthesis. The whole idea of Darwinism can't get off the ground without this. What about the N constant, the electromagnetism to gravity? This is finely tuned to 1 part in 10 to the 37th power. Are you seeing a pattern here? These are all over the place. If it was increased, no small stars. You need small stars to have a slow burn to be able to cook, to have a planet that has an equitable habitat. But if it was decreased, then there would be no large stars. So without the large stars, you wouldn't have seeded elements in the universe. So you need both. What about gravity balanced with the weak force? This is finely tuned to 1 part in 10 to the 50th power. Any larger, no galaxies. Any smaller, the universe would have collapsed by now. Now, I know I threw a lot at you there. I know that was a lot. But I'm trying to give you a feel for the enormity of these numbers. These are just incommensurable figures that we're describing, and analogies are even hard to grasp. Let's just narrow in on one with which most of us are familiar by virtue of the fact that we're tethered to the Earth and we're not flying off into space. The gravitational constant, of course, is what I'm referring to. This is finely tuned to 1 part in 10 to the 35th power, a 1 with 35 zeros. How do we get that number? Well, like I said, the force of gravity is the weakest force of all the 4 fundamental forces of physics. And the strong nuclear force is very strong. That's the one that helps atoms to stay together without flying apart, the electrons and protons and neutrons, etc. The strength of gravity is 10 to the 40th power, and the life-permitting range of the strong nuclear force to the force of gravity, the range where we could possibly have life, is about 100,000. So if you could turn the radio dial anywhere from 1 to 10 to the 40th power, a 1 with 40 zeros, there would be a 100,000 range in which you would have life. Now, if you have 10 to the 40th power, and that's how many possibilities that you have, and you buy 100,000 lottery tickets in that lottery of 10 to the 40th, that would be a drop in the bucket compared to what we see in the denominator. So in other words, if we just had one ticket, we could lower the possibility not from 10 to the 40th, but 10 to the 35th. If this was weaker, stars wouldn't get hot enough to create carbon. There would be no supernovae that would seed the universe with heavy elements. If it was stronger, we'd have only short-lived stars and elements heavier than carbon and oxygen. That's all that we would have. So again, F is the force of gravity, G is the gravitational constant, M1 is the mass of one object, M2 is the mass of another, divided by the radius squared. All those numbers could change except for the gravitational constant, which is finely tuned to 1 part in 10 to the 35th power. Let's see if we can get a feel for some of these figures here. Let's say that you're going to play the Powerball and you're feeling really lucky. The odds of the Powerball are 1 in 300 million. So 1 in 300 million. If you won that, you would be thinking, okay, I'm either extremely lucky or somebody rigged this for me to win it. What about another example? How many cells are in the human body? There are roughly 37.2 trillion cells in your body. So imagine if a doctor said, in order for you to live, what we need to do is pull out 1 cell in your body at random. And if we can do that, then you'll live. Would you sign up for that surgery? Or would you just resign yourself to the fact that that means that you're going to die, right? That number, 1 in 37 trillion, doesn't even compare to what we're seeing here. Let's try harder. How many seconds has the universe been in existence? If you were to calculate this in seconds, 13.7 billion years is 10 to the 18th seconds. So a 1 with 18 zeros after it, amount of seconds. So again, that's not coming close to our figure of the gravitational constant's fine tuning. Let's try harder. What if we had just a bird's eye, God's eye view of the entire material universe, some 20 billion light years across? If we could look at the entire universe from a God's eye perspective. And let's say that we had a God-sized Stanley tape measure, and we stretched it all the way across the entire material universe, and we broke up the universe into inches. If the fine-tuning was 1 inch weaker, that would mean death for the possibility of life prohibiting. If it was 1 inch stronger on that measurement, that would mean it was life prohibiting, not life permitting. It would need to be exactly on the right inch on a measurement on the scale of the entire material universe. The only problem with this illustration is that this is only 1 part in 10 to the 28th power. This still isn't even getting close to 10 to the 35th power. So what are we seeing here? We are seeing, in effect, that these numbers are astronomical, but it gets worse. I hate to keep beating this horse that's already dead, but think about this. The lambda constant, the cosmological constant, this is finely tuned to 1 part in 10 raised to the 120th power, a 1 with 120 zeros, the cosmological constant. If it was any larger than this, it is that small, 0.00000, 120 zeros, and then a 1 or a 2 at the end. If it was any larger than that, the universe would consist of a hydrogen and helium soup. definitely not propitious for life. That's for sure. It would not be life permitting if we just lived in a hydrogen and helium soup. What about the low entropy of the universe? Even worse. Roger Penrose says that you can't even write this number. He says he has to cheat and use two exponents. 10 raised to the 10 raised to the 123rd power. Penrose says that if you were to write a zero, catch this, if you were to write a zero on every subatomic particle in the universe, that's about 10 to the 80th particles, you wouldn't have enough zeros to write this number that we just looked at. That's the low entropy of the universe. We can't even write this number. We would need multiple universes to even write this number that Penrose is describing here. So, we're seeing a confluence of different laws, constants, and initial conditions. Just one of these, if it was discovered, just one of them would demonstrate design. Just one. But we're seeing many of these constants. How many, would you say? Well, roughly 30 laws, constants, and initial conditions. We need to not just have one of these, hit the cosmic jackpot on one. We need to hit it on 30. This is just to have the possibility of life. Not that life would therefore be required, but to even make it possible to have life.